Find the area of the region between the x-axis and the curve f of x equals x cubed minus x squared minus 2x for -1 less than or equal to x less than or equal to 2. If we're looking for the area, that it implies that this is the total area, not the net area. Because this function can be either negative or positive, we should sketch the graph of this function. To sketch the graph of this function, we first factor out x, and we have x squared minus x minus 2, and we can factor out the quadratic even further, x plus 1 times x minus 2. And so we see that there are three x-intercepts for this graph f of x, and they are 0, -1, and +2. This is a cubic function, so we will see that it is increasing, decreasing, and then increasing again. We can simply sketch the graph real quick using the procedure of graphing that we studied in the previous chapter. And this is the graph of f of x. We're looking for the area from -1 to 2, and again, this is the total area, not the net area. We can see that the total area is the area of the two regions. We will have to compute the area of each of the two regions separately. If we set up the integral from -1 to 2, what we end up with will be a negative number, and that is not good. And that negative number is not the total area that we're looking for. And so the area, by looking at the graph, and this is why we should always sketch the graph, the area is the integral from -1 to 0 of f of x dx, because from -1 to 0, the curve is above the x-axis, plus the integral from 0 to 2, but this time we would need to take the absolute value of f of x, because this time from 0 to 2, the curve is below the x-axis, and so we would need to take the absolute value to have a positive area. And again, this is the total area that we're looking for. First, we need to find an antiderivative of f of x, so that when we take derivative, we have the little f of x. F of x is x cubed minus x squared minus 2x, so the antiderivative of f of x has to be, using the power rule, x to the fourth over 4 minus x cubed over 3 minus 2 times x squared over 2. Simplifying this, we have 1 over 4 x to the fourth minus 1 over 3 x cubed minus x squared. And we should check this. If we take derivative of uppercase f, which is this expression, we need to get f of x back. Derivative of 1/4 x to the fourth is 1/4 times 4 x cubed, which is x cubed. Derivative of -1 over 3 x cubed is -1 over 3 times 3x squared. -1 over 3 times 3 is -1 x squared. Derivative of x squared is 2x. And so yes, this is an antiderivative of the integrand f of x. Using the fundamental theorem of calculus, the integral from -1 to 0 of f of x dx is therefore f of 0 minus f of -1. And so we would plug in 0 into this antiderivative uppercase f of x. F of 0 is 0, 0, 0, 0, minus f of -1. This is 1 over 4 times -1 to the fourth, minus 1 over 3, -1 cubed, minus -1 squared, and we need to use the bracket around this because of the negative sign. This is negative. -1 to the fourth is positive, so we have 1/4. -1 cubed is negative. -1 times -1/3 is positive 1/3. -1 squared is positive 1 minus 1. And simplifying this, we have The first two terms is 3 plus 4 over 12. This is minus 1. And so this is negative of 7 over 12 minus 12 over 12, which is negative 5 over 12, which is positive 5 over 12. And so the first region has an area of 5 over 12. The second region is the integral from 0 to 2 of the absolute value of f of x dx, and this is the absolute value of f of 2 minus f of 0. We know that it will be negative, so we take the absolute value. F of 2 is 1 over 4, 2 to the fourth, minus 1 cubed, 2 cubed, minus 2 squared. Minus, we know that f of 0 is 0. This is 2 to the fourth is 16. 16 over 4 is 4. Minus 2 cubed is 8. 8 over 3. Minus 2 squared is 4. So we end up with negative 8 over 3. But don't forget that we take the absolute value of this, which is 8 over 3. And so the total area that we're looking for is 5 over 12 plus 8 over 3, where the common denominator is 12. And so this is 12 in the denominator. 5 plus 8 times 4 is 32. And so the answer we're looking for is 37 over 12. The exact answer, not a decimal.